Hi everyone. In this video I want to talk about how to add, subtract, and multiply radical expressions. So let's take a look at adding and subtracting. So the idea here, we want to think about what we did when we had variables. Remember that if we had something like 5x minus 3x, how can we simplify this? Well, these are considered to be like terms because they have the same variable part. You can think of x representing the amount of something like apples. If I have 5 apples minus 3 apples, then 5 apples take away 3 apples leaves me with 2 apples. So because the variable parts are the same, it's apples minus apples, I can just combine the coefficients to get my answer. Whereas if these variables were different, I wouldn't be allowed to do that. 5 apples minus 3 oranges doesn't make 2 apples or 2 oranges because they're not the same thing. I can't combine them like this. So the best you can do is just leave it like it is. You can't simplify this at all. So when these are like terms, when the variables are the same, we can combine them and just combine the coefficients. When the variables are different, we can't combine them. We just have to leave it like it is. Can't be simplified. So we're going to use the same rationale when we deal with radicals. So if I have something like 8 root 2 minus 5 root 2, I can combine these because the radical part is the same. I have 8 of these minus 5 of these, so that means I have 3 of these. So just by subtracting 8 minus 5, I can get the answer here. Whereas if I had 8 root 2 minus 5 root 3, well, nothing you can do here, right? It's like apples and oranges, can't be combined. Root 2s and root 3s are different. So it is already simplified. I just leave it like it is. That is fully simplified. So we have to look for when the radicals are the same. That's when we can combine them. However, we do have to be careful here because there are instances where even though the radicals look different at the beginning, turns out we still can combine them. So let me show you an example of this. Suppose we wanted to simplify root 27 minus root 75. You might at first glance say, oh, can't be combined. These are different radicals. Nothing can be done here. But what we should always do whenever we approach a problem is think about simplifying it. If not at the end, then at the very beginning. And here we are. We can try to simplify this right now. And so how do you simplify radicals where you try to factor out the largest perfect square? Well, 9 is a perfect square factor of 27. So I can write root 27 as root 9 times 3. And 25 is a perfect square factor of 75. So let's factor out 25. Now when I do that, I see that, this is root 9 times 3 is the same thing as root 9 times root 3. Root 9 is 3. And root 25 times 3 is root 25 times root 3. And square root of 25 is 5. And look what happened. When I simplified these, I realized, oh look, the radical part is the same now. So now I can combine these. 3 minus 5 is negative 2. So the answer is negative 2 root 3. So always think about simplifying when you approach these problems because it may turn out that you can, in fact, combine them after simplification. So that's adding and subtracting. That's the basics of that. Let's talk about multiplying. Let's look at this example. 2 root 3 times 3 root 15. How does multiplication work? Well, it actually, I think, is a little bit more straightforward than adding and subtracting because when you multiply, you don't have to worry about like terms. You just multiply. So I multiply the coefficients together, negative 2 times 3, that's negative 6, and I multiply the radicals together. Now remember, we have a rule for multiplying radicals. Root A times root B is the same as root A times B. So we can use this rule. Root 3 times root 15 is the same thing as the square root of 3 times 15. 3 times 15 is 45. No need to worry about like terms here. Just multiply them together. But keep the non-radical parts and the radical parts separate, right? Now, are we done? Well, no, because we should think about simplifying. To simplify this, we look for perfect square factors of 45, and sure enough, there is one. 9. 9 is a perfect square factor. So I can factor out a 9. This is 9 times 5. And because 9 is a perfect square, we can take the square root of it. Square root of 9 is 3. And now I can multiply these together. Negative 6 times 3 is negative 18. So the answer is negative 18 root 5. So that's how we deal with multiplying radicals like this. We can also deal with radicals when they are a mix between multiplication and addition. So let's try this one. We're multiplying root 7 times this sum. Well, whenever you multiply by a sum or a difference, we distribute. That's when you distribute. So distribute this root 7 across. So this is going to be root 7 times 5, or 5 root 7, plus root 7 times this. All right? So it's going to be 2 times root 7 times root 7. What's root 7 times root 7? Well, that's root 7 times root 7 is root 7 squared. But what is the square root of 7? It's the number that when squared gives you 7. So by the very definition of square root, this is equal to 7. So this is 5 root 7 plus 2 times 7. This is 5 root 7 plus 14. And I should look through here, see if anything can be simplified, and no, nothing else can be simplified. So we are in simplest form, we're done. Let's do one using cubed roots. Do the cubed root of 6 times 4 plus the cubed root of 12. Okay, same idea. We're going to distribute here. So I'm going to get cubed root of 6 times 4. That's 4 cubed root of 6. Cubed root of 6 times cubed root of 12. Well, that's same idea. When we do this, when we multiply two radicals together, no matter what the index is, this rule still holds. So use that rule with the cubed roots. When we multiply cubed root of 6 times cubed root of 12, we get the cubed root of 6 times 12. Now, what you might be tempted to do at this point is combine these. 6 times 12 is 72, but I wouldn't do that. I wouldn't do that because we're going to simplify this thing. And when you simplify a radical, you want to break it down. You want to factor it apart to see where the perfect cube factors are. So it's already partially factored apart. So why put it back together if we're just going to factor it apart more? It's kind of going backwards. So let's just leave it 6 times 12 and continue factoring it down. 6 factors as 2 times 3, and 12 factors as 6 times 2. And I can factor it further. Well, the 6 at least. 6 factors as 2 times 3. So this 6 times 12 is the same as 2 times 3 times 2 times 3 times 2. All right? So let's write that down, but compress it a little bit. 2 times 2 times 2 is 2 cubed. And 3 times 3 is 3 squared. That's 9. I left this 2 cubed because I wanted us to see that we're taking the cube root of 2 cubed, right? And we know that the cube root of 2 cubed is just 2. So, cube root of 9. This cannot be simplified because 9 doesn't have any perfect cube factors. So we leave it like this. That is our final answer. One more problem, and that's when we multiply two sums or two differences, or a sum and a difference together. So let's take a look at that, the last example. All right, so our problem will be 7 minus 2 root 5 multiplied by 4 plus 9 root 5. Okay, so what do we do here? Well, when we multiply two binomials together like this, we take the 7 times the 4 That's 28. 7 times 9 root 5. 7 times 9 is 63. So this is 63 root 5. Negative 2 root 5 times 4 is negative 8 root 5. And these two terms here multiplied together. Well, the negative 2 times the 9 is negative 18. And root 5 times root 5, right? That's root 5 squared. Okay? Well, let's see what we get here. We get 28. These two terms can be combined. Look, they're like terms. They have the same radical part, right? Just like the first example we did, the very, very first one. So they can be combined. 63 minus 8 is 55. And what is this? Well, root 5 squared is 5. Square root of 5 is the number that when squared gives 5, so by definition, it's 5. So this is 18 times 5. 18 times 5 is 90. Okay, so keep going with this. What are the like terms here? Well, this guy is just an integer. This is an integer, so they are like terms. They can be combined. 28 minus 90 is negative 62. And then this is not a like term, so we leave it separate. 55 root 5. And so that is the final answer. And that's all we have here.